Hello everybody. We're going on to our fourth tutorial for this little series. Fourth part. Today we'll be covering animation and additionally hopefully animated sprites. So the important part of this is we'll probably not touch on character and player right away. Wherein we'll just really touch on this and maybe control, and then we'll just display a character to the screen, and then we'll move on to tiles. Because the player and the character aren't really important until we start talking about putting other things on the screen like mobs. So let's just start right off with animation class. This is again, we won't really be able to rephrase that. We won't be stepping in to new territory that's not in other tutorials. Like this and most of the tile engine is still gonna come from halfway, at the very least, from the same tutorial that we use for the Screen Manager, same site. More or less because 2D tile engines in XNA, they're, at least for like rectangular, like non-isometric, they're eerily similar. Because what do? You create a tile. Okay, now what do? I create an array. You know, two-dimensional array. Okay, I populate the array. Cool. It's really easy to create the same kind of feel. So, but moving on back to animation, we create an animation key. It's an enumeration down, left, right, up. That's just a way to call the 4 different kinds of animations, because when you got the 4 different kinds of animations, you got one moving up on the screen, so you got the back, right, the right side, left side of your body, and then down the whole front. We implement iClonable, which is just cloning of the class, but with the same values as the existing instance. So says Visual Studio. Now we have a rectangle array of frames because of how these animations are set up, how the pictures are set up. It's like one rectangle, and that's the sprite, and it's the next rectangle, and it's the sprite in a different position, and it does that like however many times. And it usually does like 4 of each kind of visual, so it might have like 4 slightly different ones that move to the right, so it shows them walking and things like that. And frames per second, just how many frames per second. Frame length and timer, that's just a way to keep time. Current frame, which one we're on, frame width, and frame height. Variables. Moving on to the animation, we take in a couple of parameters. The frame count, width, height, the X offset, and the Y offset. So looking into it, we're initializing frames, and the size of the array is the frame count that we pass in. So that's very dynamic. We're setting frame width and height to whatever the variable is here. In the for loop, we're going from 0 to less than frame count, so that's good. And you're saying for each frame in the array, you're creating a new rectangle, and it's the offset plus the frame width times the index. Also, let's see if we can do this real quick. There we go. The X, like the position X coordinate, is the offset, and then the frame width times the index. So that's how you figure out where it is on the picture. The Y offset is the Y coordinate. Navigate. Damn. There we go. And the width is frame width, and the height is frame height. Frames per second is 5, and then we call reset, which is down here, which just sets the current frame equal to 0 and the frame timer time span 0. So going back, there's a second constructor that takes in the natural class animation, and that just sets the animation.frames equal to that, or the frames equal to animation.frames. This little guy, and frames per second 5. So frames per second, we're saying if it's less than 1, set equal to 1. If it's greater than 60, set equal to 60. Otherwise, it's going to be set over whatever the value pass in. And then frame length is equal to time span from seconds 1 divided by the double frames per second, or double typecasted frames per second. This is accurate to the milliseconds. That's crazy. Current frame rect just gives us that back. Current frame rectangle. Current frame because it's the current frame. And you gotta. So what clamp does? So if I were to, it's really good for like random and stuff like that. But we're restricting a value between 2 points, more or less. So in this case, we pass in a value, okay, and that's the value. So then the minimum is 0, and the maximum is frames.length minus 1. Now that's because you know how with arrays it starts at 0 instead of 1, so that's just way with arrays. Frame width, get set methods. Public void update, on the other hand, we're increasing the frame timer by elapsed game time, so that's that increment. And if it's greater than the frame length, so if the timer ever passes how many frames we have, we need to start that back to 0. So that's how we keep looping the animation. Frame timer is equal to time span at 0, and the current frame plus 1 because of the array, and then I believe that's called a modulus. Mod frames at length. Once again, I'm kind of expecting a small knowledge of programming in general. But if need be, I can go into all of these again in a greater detail, like really like super line by line, explaining this, explaining arrays, but that would really have to be like if a lot of people ask for it. And then we already talked about reset and clone is how you can get things like this. So clone's really just we're creating our variable of animation or instance. We're initializing it. We're basically saying everything that's in this class, the frames, the width, the height, just take ours and set whatever ours is to, or set whatever this is to ours. So all of this, like this is like null right now, and we're just setting it all to whatever it is. So the frames is equal to our frames, frame width, our frame width. And then we're calling reset, so it resets their timer, and then returning the clone. Don't want to save that. Don't know why I changed. Animated sprite. So we're keeping a dictionary of animation classes, more or less. And how we're distinguishing what we need to do is by the key. So that's that whole up, down, left, right thing. We're calling that animations. And the key itself, we're calling current animation. So that's what you are currently animating, up, down, left, or right. And is animating, so if we want to loop, texture is the texture for the picture, which usually looks like a rectangle separated into like 4 or 5 squares, or however many squares it is with the, let me rephrase that, it's usually a square, actually, if it has all of the textures in one, and it'll be like rows, like it'll be like a 4x4 or something, or a 5x5, and it'll be like all left, all right, all up, all down, and that's how that works. And it works in rows. Position, velocity, speed, we'll get to that once we start talking about it down here. We got some get set methods, returning current animation, setting equal to a value. Same thing with is animating, width, height, speed. Speed on the other hand, let's talk about width for a second. Width, it goes in to our animations dictionary. It takes in the current animation, where it is right then, and then it gets that frame width. So that's that array. Speed on the other hand, so we're returning speed, and if we want to set it, once again we're using clamp. So it's going to be between 1 and 16.0, so that's that float. Position velocity on the other hand, this little snippet right here, if velocity does not equal vector 2.0, or velocity.normalize, what this is saying is if you look at a triangle, so you can go right and you go up, and those two might be at the same speed, but the hypotenuse is going to be larger. So if we were to go to paint.net for a second, no, is it pencil that does that? Okay, well we have this triangle, okay? Let's say we got this triangle. So you have A, B, C, standard. A squared plus, about to do some math. Okay, so if this is 5, if A is equal to 5, oh, mouses. B is equal to 5. Moving up and moving to the right on different points, those are going to operate at the same speed. But moving up and to the right, so moving this way, that's going to give you, if we were to figure out what C is, or up and to the left rather, if you have to figure out what C is, it's going to be 25, whoa, wow, plus 25, which is equal to 50. Then you have to square root 50. And if you square root 50, you notice, oh snap, it's larger than 5. So we need to normalize that. And what normalize is just setting it equal to 1. So it takes the current vector, and then result is a vector 1 unit in length. So a vector 1 unit, so 1, in length, pointing that same direction as where it originally was. Going into animated sprite, we're passing in a texture, so this is the constructor, passing a texture and a dictionary, and we're setting that equal to the, basically creating the variables, not creating, setting equal to variables. Update comes in where that whole is animating thing, so if we want to animate, then take in animations, pass in the current animation up, right, left, down, and update that. Draw, sprite.draw, texture, position. So if we look into sprite.draw, we have the texture 2D texture, the position, which is where we want to draw it, the destination rectangle. So the position on the screen, that's where we want to draw it. Animation, bam. Source rectangle is what we're drawing from, so like the picture, or must the position on the picture. So that's where we get that current frame rectangle. So that just reaches in to our picture and says, "Oh, we're right here." Grabs that, and then color.white is not really important. You just need to know if you, so the color is a tint, and color.white is no tint. So if you just want it to look like it already looks, just pass in color.white. And lock to viewport is something we'll get into in a little bit once we actually start drawing it in the screen. But it's just a way to keep the position of our guy in the same spot more or less on the screen. So instead of having, so let's say if you can see my mouse, let's say this is the whole screen, and when I move around, instead of having the camera move around and the guy staying in the same place, the guy, when the guy starts moving, the camera will follow him. So that's good. Nope, I'm not gonna save that. So we have animation and animated sprite done. So moving on, we'll probably go. Let's look at character real fast, or not player. Let's look at character real fast though. Player, just not much to it. Just a way to distinguish male from female, but it inherits from character. If we look at character, let's do some quick stuff right now. We can just pass in Sprite. Alright, so what I just did, whoopsies. What I just did is I just extended, or I inherited character. So I'm creating player, that's a child class, the character class. And character in its constructor requires an animated sprite. So player therefore also requires one. And I don't want to do the same thing here, so I just go, hey, give me an animated sprite, I'll pass it back into character, and then it'll handle everything because it's already got the code for it, so I don't need to write it again. So if we look into character, it's got an attribute pair, which is just a way to manage health and or stamina, vitality, anything that's kind of like anything that's based off a current max value system. So if you have a current value and a maximum value, so if you have like, let's say 500 health and your maximum is 1,000, it's just a way to stay in between the 0 and the 5,000 without going over, without going under, to increment, decrement, and do all those things. So it allows you to keep track of everything. We also have an animated sprite, a position of the vector too, so its position on the screen. Drom is what we decided to call the money. That's subject to change. Character name, that's a string. Is the character alive, so we know when to display the dead screen or subtract a life, whatever it is. The level, experience, how much they're worth. So experience worth, since character, mobs, NPCs, bosses, they all take away from this character class, which is why it's called, character, not player. Because so what we want to do is you want to say, okay, we want a way to work with characters, mobs, players, NPCs, all those things in one class, in a really vague way, and then define it more through other ways. And so that's why we have experience worth, because mobs are worth experience. Constructor, in the update we just check if the health is less than or is equal to 0. Let's make that less than or equal to 0. Then set is alive false, and immediately checks is it false, and if it is, right now we just have it set to return, but we can later show a dead screen and delete the character because it's permadeath, or maybe not permadeath. But then we go to draw, and that just animated sprite handles the drawing, and there's a clone. So it's a very quick look at character. We'll touch on more of that later. Don't forget to like or dislike the video, depending on how you felt about it. I'd love some feedback, and just keep on watching, guys, and see you guys in the next tutorial.